Hello, students. This question is on the longitude and latitude. What an interesting topic. Now, listen, an aircraft leaves a town P. We have the coordinates, and after flying for 1450 kilometers due east, very important, it gets to another town Q, then flies due north to another town S on a latitude of 60 degrees north. We should calculate Roman figure 1, the radius of the line of latitude through P, that is latitude of P. Then Roman figure 2, the longitude of Q correct to the nearest degree. Then the distance between Q and S correct to the nearest three significant figures. Now everything correct to the nearest three significant figures. So let's move ahead and solve this question quickly. Now, solution. First, the first thing you need to do, you have to sketch. So I'm going to sketch my Earth. It's actually a geoid, but I'm going to use a circle to actually represent my Earth. All right, so let's move it this way. Okay, good. So I have a perfect circle for my Earth. Now, the next thing I need to get will be my Greenwich meridian line, which actually divides the earth like this. All right, so let me have it this way. Okay, we have my Greenwich meridian line. Then I'm going to have my equator. All right, so this is my equator. Now, since I have this, remember this. Equator is actually at 0 degrees, and so also that is horizontally now, and so also the Greenwich meridian line is actually 0 degrees vertically. So we take note of that. All right, now the first point P, we are told that it is 40 degrees north and 52 degrees east. So we'll go straight to get our point. So 40 degrees north. Now listen, the latitude, lines of latitude, they are parallel. They are the parallel ones. Okay, the lines of longitude are the vertical ones. Now, lines of latitude actually increase like this, okay, down from 0 to 90 degrees. So from 0 to 90 degrees. So since we are told that P is 40 degrees north, so we will come here. We are going to assume that this place should be 40 degrees north. Okay, so I have my 40 degrees north. All right, I'm going to write it 40 degrees north. And we're told that, okay, 52 degrees east. So I'm going to take this as my 52 degrees east. All right, very important. Good. So this is my longitude of 52 degrees east. Now, at this point is going to be my point P. All right, so I've gotten my point P. And all right, good. And after we were told that after flying for 1450 kilometers due east, so this is what happens. Now from P, it moves due east, but we don't know whether it crossed this to this side, that is the west, or actually it stayed at the east. But we're about to find out. So let's move ahead to see how we get that. Before we can actually find out that particular thing, we have to answer the first question, which is the radius of the line of latitude through P. So now, like I said, we'll move to find the first question, which is the radius of the line of latitude through P. Now, this is what this question is talking about. That is 1. Now, this is the ring that houses the latitude of P. All right. And at this ring, we have, it is actually 40 degrees north. Now, the radius, which is going to be this small r, okay, this small r is actually having the formula r cos alpha, where this alpha refers to the angle of the latitude. So r is actually going to be 6,400 being the radius of the earth, because capital letter R is 6,400 kilometers. All right, take note of that. Then it's going to be cos 40 degrees. Then quickly we move to our calculator to make sure we get the answer to this. And if we do it well, we are going to end up with 4902.68. So R is approximately to three significant figures, which is going to be 4900 kilometers. All right. So that is exactly what we supposed to get as our answer. Now, let's move to Roman figure 2, which I said is going to actually help us to know to what extent it has moved or where Q will be. Now, from the diagram or from the question, you agree with me that PQ is actually 1450 kilometers. Now, one of the things you must ask yourself in solving this question, PQ, along what? Now, PQ is along latitude 40 degrees north, and latitude 40 degrees north is actually a parallel of latitude. What do I mean by parallel of latitude? They do not divide the earth into two equal parts. It's not a great circle, all right? Great circles are circles that divide the earth into two equal parts. So all lines of longitude are great circles, okay? All longitude are what? Great circles. Then except the equator, okay? All latitude, okay, except the equator are known or referred as parallel of latitude, and their radius vary. Okay, so therefore, since PQ is on the parallel of latitude, to get PQ, which is actually an arc of that particular latitude, is going to be theta all over 360 times 2 pi. We are going to use small r because it's not to the radius of the earth. So we use small r. Now, we have to understand this formula. What is the meaning of theta? Theta is angular difference. Okay. Now, this angular difference will help us to locate where Q is. Now, let's look for it. We know that PQ is 1450, good, is equals to theta all over 360 times 2 times 22 by 7, then times r. Now, this r we are talking about is for the latitude of 40 degrees north, which we've actually calculated. So, we are not going to use the approximated value. We are going to use the raw value, which is 4902.68. Now, quickly, you pick your calculator and make sure you get it right. Now, we can actually write this as 1450 times 360 times 7 will be equals to 2 times 22 times 4902.68, then times theta. Now, in getting theta, my theta will be equals to 1540 times 360 times 7 all over 2 times 22, I think that is 44, then times 4902.68. Now, this is purely work that we can actually impute in our calculators and get our answer. Now, doing that, we will come back that theta is going to be 16.94 degrees. Now, let me tell you something. For the fact that the angular difference is actually smaller compared to this latitude means that they must be in the same direction. Because for us to actually work out our angular difference, we said if they're on the same direction, we subtract. Then when we're on different directions, we add. Now, since they are on different directions, we can now see that our theta is going to be the longitude of P minus the longitude of Q. All right. And remember, that is what we are looking for, the longitude of Q. So therefore, we are going to have 16.94 is going to be equals to 52 degrees minus Q. And we have our Q degrees is going to be equals to 52 minus 16.94. Then our Q degrees is equals to 35.06 degrees, which Q degrees approximately is going to be what, 35 degrees. But of course, like I told you, it must be that they are of the same direction. So it has not yet crossed to this point. So we'll still maintain east. It is very important you have to write the direction. So it is east. So this is our answer. All right. So we are almost through. Let's go. I think we have one more question. All right. The question is the distance between Q and S, and where can we find our S? Let's go to the question. We are told that it then flies due north to a town S on the latitude 60 degrees north. So in this, it actually moves northward. So therefore, we can actually have our 35. Let's say this is 35 now. Let's put it this way. So this is going to be, let's say this is 35 degrees east. Now, this is my point Q by our calculation. So it is now moving. All right. It is now moving from Q. It goes up to 60. So let's say this is a 60. All right, these are latitude 60 degrees north. Okay, now this juncture at this intersection is our point S. So we actually need to find QS. All right, distance between QS. So to find distance QS, we come here, Roman figure 3, QS. Now, if you check very well, QS is on a longitude. Okay, it's on a longitude, and that is longitude 35 degrees east. And what do we say about lines of longitude? They are all great circles. So therefore, my QS is going to be, let me use beta this time around to represent angular difference, all over 360 times 2 pi r. Now, if you check, there's something that you need to take note of. In expressing PQ, I use small letter r, but on QS I'm using capital letter R. Yes, it is like that because there's difference between great circles and parallels of latitude. So great circles carry the big R. All right. So therefore we move. Now QS is this. Now we need to find our beta, which is the angular difference. Now, if you check the two of them, one is 40 degrees north, the other is 60 degrees north. So on the same direction. So therefore, the rule is that when they are on the same direction, we actually subtract. So to get the angular difference, which is 20 degrees. So since we've gotten that, then we'll come and get our QS now is going to be 20 all over 360 times 2 times 22 by 7, then times R, which is 6,400. All right. And I think once you handle your calculator and you work with it well, you're going to find that a QS is going to be equals to 20 times, we have 44 times 6,400, then all over 360 times 7. All right, which QS will give us approximately 2234.92 kilometers. But do not forget, we are told to leave it to 3 significant figures. So therefore, QS now is going to be 2230 kilometers. So that is the answer. This question is a very interesting question, and I want to believe you enjoy the solution. Now, if you do, please don't forget to subscribe Subscribe for more interesting videos. Thank you so much.